120 to what? Moles. If you convert it into moles, what we have 120 divided by the molar mass of potassium. Molar mass of potassium, which is our relative molecular mass of potassium, we have 39. So 120. In this question, we are going to be looking at how to calculate the mass of a substance. And the question says that 59 grams of water reacts with sodium to produce sodium hydroxide and hydrogen gas. Calculate the mass of hydrogen produced. We have the chemical equation. So for us to do this I'm going to be solving it in two methods. In stoichiometry, we have these two methods of solving problems. Then we can use moles or what? Mass. The first I'm going to be doing here is to solve it using the mass. Using the mass in solving the problem, let's look at the chemical equation. The chemical equation we have here, that will give us a clear message, the best information on how to solve the problem. Then we have hydrogen here. So in this chemical equation, if you look at it very well, what we have in this chemical equation is giving us the mass. Then we can see the mass and the mole relationship here. That is the number of moles of sodium is this. The number of moles of water is 2, and the number of moles of sodium hydroxide is that, and that of hydrogen is what? 1. But in this question, what we are asked to find is the mass of hydrogen produced. We are looking at the mass of hydrogen produced. This is the basic thing that we need here. The mass of hydrogen and the mass of water is what we were given. So based on this, what we are going to do next is that that means we don't really need this one. We don't need that, but rather what we need is this hydrogen and what? Water. So from this chemical equation, we know that to get the mass of the reactant, what it means is just that moles is equal to mass over relative molecular mass. So based on this, we can get the mass. That is, we have the moles here. So what it means is that mass will then be mass equal to mole multiply relative molecular mass. Our relative molecular mass, that of water, we have 18. 2 times 18. That will give us the relative molecular mass of what? Water that is present here. So then the other one, let's see what we have in 2 times 18. And let's just go to the calculator. 2 times 18. We have 36. 36 will give us 36, and the mass of hydrogen being a diatomic. Diatomic means that 2 atoms. It means that hydrogen 1, that is 1. Relative molecular mass of hydrogen is 1. 1 plus 1 will give us 2. So what we have here is 2. This is 1 already. 1 times 2 will give us 2. So let's just go to the question itself, how to use this information we have already. We have this one to be what? 36 mass. So then what we are doing again is that since we know that 36 grams of water will give us 2 grams of hydrogen. 2 grams of hydrogen. So what will this 59 grams give us? 59 grams, remember this is from the balanced chemical equation that we have. From the balanced chemical equation we notice that 36 grams of water will give us 2 grams of hydrogen. So for that reason, we'll go back to what we have. We are given 59 grams. 59 grams of water will then give us 2 over 36 multiplied by 59 over 1. So what do we have here? What we have will be, we are going to get 2 times 59 divided by 36. What we have is 3.28 grams of what? Hydrogen. Now, another method of solving this problem, method of solving it is considering the moles. But before you use the moles, you need to convert these grams to moles. Converting the grams to moles means we know that water, relative molecular mass of water is what? 18. So what it means here is that mole, we know that mole is equal to mass over relative molecular mass. So what we do here is the mass given to us is 59 over what? 18. That is what we have. 59 over 18. 59 divided by 18. We have 3.278 watts moles. This is what we have. Now we can now compare it based on what we have here. Remember, we can look at what we have. Based on what we have from the balanced chemical equation, we have 2 moles. Means that 2 moles of water will give us 1 mole of what? Hydrogen. 2 moles of water will give us 1 mole of hydrogen. So 3.28 moles of water will then give us 1 over 2 times 30, 3.28 over 1. That will give us it will be about 1 point, let's check, divided by 2, 1.64 approximately moles. So now that is what we have as the number of moles. Now to get the mass using this method, because we started from moles, because whenever you solve with moles, depends on the question given to you, because the question needs the mass. So we need to convert back towards the mass. So we know that mass, to get the mass now, since moles is equal to mass over what? Relative molecular mass. It means that mass will then be equal to mole times what? Relative molecular mass. That relative molecular mass of hydrogen is what? 2 multiply 1.64. That will give us 3.28 grams. You can see that everything still remains the same. Now, if you are joining us for the first time, we want to encourage you to subscribe to our channel. So that you will enjoy our teachings. Now, another thing, if you have any question, you can also leave it in the comment section, and I will always attend to you. And then we encourage you to like and share so that the video will get to people that will actually need it. So let's continue. The next one we have here is to calculate the mass of potassium oxide produced. The mass of potassium oxide produced from 120 grams of potassium reacting with oxygen in excess. Now they say that the oxygen is in excess. Then what it simply means is that the actual thing that determines the reaction, is the 120 grams of potassium, which is the limiting reagent. So in this case, what we are going to be doing here is let's look at the chemical equation. Let's look at the balanced chemical equation of what we are asked to find out. So from this balanced chemical equation, we are going to be looking at the mass first. We are going to calculate using the mass. The mass is what we are going to use to solve this thing. First, in that case, we can get the mass of potassium that is involved in this balanced chemical equation. When we're able to get that the mass, then we will use it to relate, compare to get the mass that we need for this what's it called? We call it again potassium oxide that we produce from the mass of 120 grams of potassium. So now what we are going to do now from this chemical equation, we know that for potassium is what? Potassium is 39. That means times 39 will give us equal to or equivalent to 2 times potassium. That is the potassium. Let me get the this thing. That means the potassium is 39. Oh my god, 29 plus oxygen, which is 16. So the relative molecular mass of this one will be 94 according to the balanced chemical equation. 4 times this because of the number of moles multiply the relative molecular mass. Now number of moles here multiply the relative molecular mass, we have this. So now we are going to be looking at what we have. What will this other one give us? Then we have 120. What will this 120 give us? 120 grams of potassium. 120 grams of potassium will then give us 2 times 94 over 4 times 39 multiplied by 102. Multiplied by 102. Let's see what we will get here. Times 2 times 102 divided by. So what we have is 144.6 grams of what? Potassium oxide. So we're going to be solving it again using moles. Because like I told you, in stoichiometric we have two methods, moles or what? Mass. Now you can solve it since we want to get this. And sometimes we can also compare it based on in stoichiometric. I don't want you to make mistake in that area. We also use something like mass to mole, mass to volume, all these things, volume to mass, depending on the equation given to you. But this case, looking at the question given to us here, what we are looking at is just something that has to do with mass, or maybe mass mole. We can also solve it using this method. So let's continue and finish up what we have started. So in this case, we have done it using mass. The next one we're going to be solving it is using what? Now moles. We know that from this chemical equation we have mole, 4 moles of what? Potassium. Then with what? 2 moles of will give us 2 moles of what? Of potassium oxide. So what we do here is to convert this 120 to what? Moles. If you convert it to moles, what we have 120 divided by the molar mass of potassium. Which is relative molecular mass of potassium, we have 39. So 120 divided by 39, that will give us equal to 3.08 moles of what? Potassium. So this is what we have. So then we can now relate it effectively based on what we are given. Since we know that 2 moles of this, 4 moles of potassium will give us 2 moles of potassium hydroxide, then what will this other one? 4 moles of potassium is equal to what? 2 moles of what? Potassium oxide. So what we do now, 3.08 of moles of potassium of what? Potassium will then be equal to 2 over 4 times 3.08 0.08 over 1. So we are going to get the number of moles of this potassium oxide that will be produced. So based on that, multiply by 2, 3.08 multiplied by 2, divide by 4, we have 1.54. That is the number of moles we have here. 1.54. Since we have 1.54, then like we have done before, we know that mole is equal to mass over what, relative molecular mass or molar mass, as the case may be. So what we have here, we have our mole to be what, 1.54. Mass is what we don't know, and we know that relative molecular mass of potassium oxide should be 94. So if it's 94, then we multiply through. To multiply through, mass will be 1.54 multiplied by, that will give us, let me use the calculator. That will give us 1.54 multiplied by 49. That will give us 1.54 multiplied by 94. That will give us 144 point. This is 44.8 grams. That is what we have. All right, this is where we're going to stop for today. In our next class, we'll continue, and there will be some videos that will be appearing in these places. I want you to make sure you go through it. So it will help you to understand stoichiometry very, very well. Thank you so much for being part of the class. Bye.